Hey guys, Happy New Year, and thanks for helping me reach the 1,000 subscriber milestone. I'd like to say thank you to all of you who have supported me from the beginning. I've been looking for a chance to make another WAN 2.2 video for a while now, especially something about extending videos, since someone requested it months ago. And finally, here it is. Today I'm introducing Stable Video Infinity version 2 Pro, a powerful system that allows you to generate long, continuous AI videos that actually stay coherent from start to finish. The best part? It's free, it runs completely offline, and it even works on low VRAM GPUs. So, how Stable Video Infinity works? Instead of trying to generate one long video all at once, this system breaks the process into short, high-quality segments. Each segment smoothly continues from the previous one, which helps maintain natural motion, stable scenes, and consistent visual quality. This approach makes a huge difference compared to traditional long-form generation. Under the hood, Stable Video Infinity uses WAN 2.2, which is currently one of the strongest open-source video generation models available. I've already covered the basic WAN 2.2 setup for 8GB VRAM users in a previous video, so feel free to check that out if you need foundational knowledge. On its own, WAN struggles with long video durations, but Stable Video Infinity solves this by intelligently chaining clips together while preserving visual memory. What's new in version 2 Pro? With SVI V2 Pro, character appearance, lighting, and scene details stay consistent, even when the camera moves, characters leave and re-enter the frame, or actions change across clips. The transitions are so smooth that it's genuinely hard to tell where one clip ends and the next begins. Now let's move on to the workflow setup. I'll walk you through where to download everything you need. All the links, models, Loras, and workflows are in the description. I've also included the links inside the workflow itself, so don't worry if you can't find something manually. Some of you reported that the JSON workflow file wouldn't load in Comfy UI. If that happens, don't worry, just drag in the PNG workflow file instead. They're exactly the same. I ran into this issue myself on a previous portable Comfy UI setup, and the fastest fix was simply doing a clean install. After that, everything worked perfectly. If you really can't run my workflow, unfortunately, you'll need to try an alternative, because in this video, I'm not using my own workflow. You can download the official workflow using the link in the description. Just click the JSON file, and it will download the workflow. Making this workflow work on 8GB VRAM is actually quite simple. All you need to do is replace the Diffusion Model Loader KJ with the GGUF Loader KJ. To keep things simple, I'm still using the same Q4KS model that runs on 8GB, just like in my previous video. So this time, we're focusing on the official workflow. When you first drag the workflow in, you might see a missing node called WAN Image to Video SVI Pro. If that happens, do the following. First, update Comfy UI before updating any custom nodes. If you don't do this step first, the workflow will not work. Next, go to Comfy Manager, install the missing custom nodes, and then update KJ nodes. After everything is updated, restart the server, and you should be good to go. This step is important because the workflow relies on newer custom nodes. At first glance, the workflow looks simpler, but under the hood, it creates a subgraph node. Let's open that subgraph. Inside, you'll see that 81 frames is the default setting. We don't need to touch that for now. Here's a quick overview of the model setup. WAN 2.2 image to video requires a high-noise model to handle lighting, motion, and overall dynamics, and a low-noise model to add fine detail and clarity. Lora setup. Download Light X2 V-Distill Lora, both the high-noise and low-noise versions. Make sure you download the image to video version, not text to video. This is different from what we used in the previous video. If you use the old Lora, you'll get unwanted results, so be careful. The most important Lora you need to download is the SVI V2 Pro Lora. Make sure to download both the high noise and low noise versions. Without this Lora, Stable Video Infinity will not run. Clip setup. For 8 GB VRAM users, I'm using the official Clip UMT5 XXXL FP8. However, I need to mention that this workflow relies heavily on the text encoder. This means that if you want the AI video generation to follow your prompt more accurately, it's better to use FP16. So this part is up to you, performance versus prompt accuracy. Finally, for the VAE, use WAN 2.1 VAE as usual. Hopefully you already know where to place each model in the correct folders. If not, here's a screenshot showing the exact locations you need. I've also included this information as a note inside the workflow itself, so don't worry. If you're not using my workflow, this screenshot can help you. Let's proceed to initial image setup. Now let's upload our first image and send it to the resize node. It is recommended to use the optimal resolution, 480p or 480 by 832 horizontal. This is a key factor for staying consistent with the training data and avoiding slow motion. Inside the subgraph, under the K sampler, you'll see WAN Image to Video SVI Pro. 81 frames is the default input. For the first section clip, the motion latent count is set to 0 because we don't need previous frames yet. For the next and ongoing sections, the motion latent count is set to 1, which is approximately equal to 4 frames. This means we're using the last 4 frames of the previous clip as input for this loop. If you feel that the video is not long enough, we can extend it by simply copying and pasting this entire set of nodes. Then we connect the latent output to prev samples and connect the extended image to the source image. This is how we chain clips together and extend the video. Next, let's talk about anchor samples. The anchor sample is essentially your input image after VAE decoding. Why is this important? Because the anchor allows characters to leave the camera view and then return without changing identity. This works not only for humans, but also for objects, as long as you provide a proper anchor image. For the seed settings, it's strongly recommended to use different seeds for each loop. This helps prevent quality degradation caused by repeating noise patterns. To make things easy, just set the seed to random. One very important thing to remember is that prompt continuity is critical. Each prompt must be written precisely so that actions continue naturally from the previous clip. If the motion between clips doesn't logically connect, you may see frame jumps, discontinuous motion, and unnatural transitions. Every new action must be related to the previous action. Once you've completed the setup I mentioned, you're ready to go. After all these tedious setups, I'd like to show you how to actually play with this workflow. We'll start with the basic knowledge, cover common errors and how to fix them, then move on to more advanced techniques and how to use the workflow like a pro. Later on, we'll do some final exercises to cover everything we've learned. By the end of this video, you'll be able to make your first anime video using this workflow. First, I'm loading this image as my example. As I mentioned before, the most important part of this workflow is how you prompt your actions. You can easily do this by asking ChatGPT to assist you. Now let's try writing a prompt. I want the character to raise his hand. By the way, you don't have to generate the entire video all at once. You can simply bypass the next section and focus only on the first section. If the first section's video result is satisfactory, then you can activate the next section and proceed. My first section has 81 frames with a frame rate of 16, which results in a 5-second video. Don't forget to set the output format to MP4. Take a look at the result. If there's no problem, we can move on to the next loop. For the next loop, I want the camera to push forward slightly into a medium shot. You can ignore the action prompt here because, as you can see, the most effective prompt is the camera movement itself. The result follows our prompt perfectly. The camera zooms in toward the character's face, which is awesome. Next, we need to test image consistency. I want the character to turn around and cross the road to leave the frame. If you look at the result, the character only turns around and doesn't cross the road. This means that within this 5-second segment, the AI can only generate the turning movement and there isn't enough time to generate the road crossing action. So, never mind, in the next prompt, we'll add leaving and entering the frame. Let's see what happens. The character's facial details are maintained perfectly, with no major issues. Now, if I want to change the prompt, for example, changing the last action to walking into a store, you can do that at any time. When you click Run, you'll notice that the previous section's K-sampler doesn't run again, only this section starts running. Let's take a look at the result. This is exactly what I expected, but we call this a jump cut error, or frame discontinuity. This happens when your movement prompt doesn't match the last frame of the previous video segment, causing the AI to generate a new scene and resulting in a jump cut. This mistake can be avoided by carefully writing your prompt according to the last frame of your video. Here's the result when the prompt is written correctly. In this example, I created a character waving in front of the camera. The waving duration is too long, so I'll try reducing it by half. To do that, I change the frame count from 81 to 41 and test the result again. This is another video where the character runs across to the next street and continues running along the road. You can try any prompt to test it out yourself. Imagination is your only limit. Feel free to play around with it. Now, I'll move on to advanced techniques. When the normal workflow doesn't work due to its limitations, we'll get hands-on and modify some nodes to achieve the desired results. So now we have one character in our initial image. What if you want to add another girl into the video? If you keep using the same workflow, you probably won't get the desired result. These are examples of failed results. Let's say I want to pull this girl into the video. Without a reference image, the system will insert a random girl instead. Just like in this example, you can see the AI trying hard to drag a random girl out of nowhere into the video. To fix this issue, we need to make a small modification. I'm no longer using the first image as my anchor sample. Instead, I refer everything to the last frame of the first video and try to generate another anchor image using WAN Image Edit 2511 as shown in my previous video. I tested two images. The first image emphasizes only one girl in the frame, and the second image includes both the boy and the girl. I load these images as anchor samples, using them as references that closely match the last frame of the first video. The setup is simple. Start with load image, then resize image, get the VAE and connect it to VAE encode. Then connect the latent output to the anchor samples. Next, with the assistance of the prompt, I can pull the girl into the frame properly, and here's the result. If the anchor image doesn't match your prompt, the result will not be good. From this point on, I'll keep using the same anchor sample to generate the next loop again and again. So yeah, this works similarly to using the last frame as the starting point in WAN 2.2, thanks to the previous knowledge we've learned. If you encounter double hands or a ghosting effect in the video, you can simply modify the prompt by adding or removing some unnecessary words or change the seed, and it will regenerate the video for you. This problem can usually be solved using this technique, and I assume everyone already knows this basic knowledge. Let's talk about existing video extension. This idea comes from AI Wood, a VTuber from China. Let's say we already have a video, not a photo this time, and we want to continue the video generation using the last frame of that video. How can we do this? It's actually quite simple. First, load the video, then resize it, and pass it to these two nodes. Next, we need to extract the video information, specifically the total frame count. In this example, my video has 81 frames, so I extract the value 81 and send it into simple math integer a. For the anchor samples, we need the last frame of the video. That means the value should be set to a minus 1, which is 81 minus 1 equals 80. If I input this into the start index, it will be 80. If I set the number of frames to 1, that means starting from frame 80, I will get the next single frame, so it becomes frame 81. In this way, I'm getting the 81st frame as my anchor sample. That's the logic behind it. Next, if you want to get previous samples, as we mentioned before, we need at least 4 to 5 frames as our sample. So again, we use simple math to calculate 81 minus 5 equals 76, and use this value as the input for the start index. Starting from the 76th frame, setting the number of frames to 5 will give us the next 5 frames, which are effectively the last 5 frames of the video. Connect this output to prev samples and it will do the job. Oh yeah, don't forget to connect the K-sampler samples to VAE decode samples and set overlap mode to cut, and that's the result. By combining the original video and the extended video, they become one complete video. After all of the explanation, let's do some exercises to strengthen the knowledge we learned today. With this image provided, let's try to animate our first anime scene shot. I'll give you 1 second to think about it. Ready? Let's begin. First, we load our image, then we resize the image and set it as the anchor sample. Our first prompt is hug together. We can check if there are any problems, and then we proceed to the next prompt. This time, we want them to release the hug, and the guy holds her face softly. However, in the result, the guy doesn't hold her face. This is what I was expecting, but this is the output we got. Still, the result looks okay, so never mind, let's proceed. Next, I want them to kiss, and the camera to slowly push into a close-up, and the result is perfect. Now, I want to separate them from the kiss and let the camera zoom out. I want the guy to walk away. The camera follows him, and the girl stays behind and gradually leaves the frame. It follows perfectly, even when using the FPA text encoder. Since this video doesn't walk to the fence yet, the next prompt emphasizes the man reaching the fence and leaping over it. All right, the last one will be jumping into the sea to continue the motion. And there it is, we've finished our first anime. Not too bad, huh? What's the best part is that all of this can be done with 8 gigabytes of VRAM. Very amazing. Now I'm going to show you some modifications to this workflow. I'm replacing the base model with Smooth Mix 1 2.2 and comparing the original base model with the Smooth Mix 1 2.2 model. Because Smooth Mix 1 2.2 has a built-in Light X2V Lora, I need to remove the Light X2V Lora manually. I'm not sure if you can see any difference between these two videos. According to the author, and based on community feedback, slow motion issues can often be mitigated by disabling Light X2V and using the Smooth Mix model instead. Also, don't forget to adjust the Lora strength to 0.8. You'll thank me later. Oh yeah, let's give a quick update on an error we fixed recently. Thanks to my lovely community who were willing to spend their time testing and solving the problem together in the comments section, I want to give them some credit. While using Kijai's workflow, we discovered that the OOM error is caused by fully occupied system RAM when using block swap to reduce GPU VRAM stress. Reducing the block swap value to 20 can lower RAM usage and help avoid CUDA out-of-memory errors. That's why some users with 8 GB of VRAM can run my workflow, while others cannot. Hopefully this workflow will run perfectly on your 8 GB VRAM setup, because it has been proven by the community that this GGUF model can run successfully. I've repeated this theory and setup again and again in each of my videos, so I believe I don't need to clarify it any further. If you like this kind of content, make sure to like and subscribe to my YouTube channel. I'll see you in the next video.